Before we get into ionic bonds, we need to understand a few things about orbitals and valence shells. So let's take hydrogen. Its atomic number is 1, so there's 1 proton in there somewhere. And here's our 1 electron in that first orbital, or first energy level. Helium's atomic number is 2, so there's 2 protons in there somewhere, and there's the 2 electrons in that orbital. But how do we know how many to put in this orbital? You can see that some atoms have more than 1 orbital. Well, that's where the octet rule comes in. It says that the first shell, the shell being the orbital or energy level, the first shell can hold 2 electrons, like this. Each subsequent shell can hold 8 electrons. So if there's a second shell, it can hold 8. If there's a third shell, it can hold 8, and so on. So it's 2, 8, 8, 8, continue. Let's take carbon for an example. Carbon's atomic number is 6. So there are 6 protons in the nucleus. They're not showing the protons in this image. So let's distribute our 6 electrons. How many go in the first shell? 2. Now we have 4 left over, and we put the 4 in the second shell. The second shell can hold 8. That means that carbon would like to react with another atom because its outer shell, which we call the valence shell, is not full. So the valence shell is very important. It's the outer orbital, and that determines how the atom reacts, which we're going to get into. Let's take neon, for example. If you look at the periodic table, you'll find that the atomic number for neon is 10. So there's 10 protons in this nucleus somewhere. Let's distribute our 10 electrons. 2 go in the first energy level. We have 8 left over. 8 go in the second energy level. Well, neon looks like its valence shell is full. So neon does not react with any other atom because its octet rule has been met and it's satisfied. We call these types of atoms noble gases, or inert, meaning unreactive. And they're all in the same row to the right of the periodic table. Helium is 1. Notice that its valence is full. Its outer shell, which is only shell, has 2, which is what the first shell wants. Helium, neon, argon. There's various elements that are noble gases. Let's go through ionic bonds. Here's sodium. Its atomic number is 11, so there's 11 protons in this nucleus, although it doesn't show us. When we distribute the 11 electrons according to the octet rule, 2 go in the first, 8 go in the second shell, there's going to be 1 left over in the third shell. Now the third shell member wants 8 electrons, but there's 1 there. So this atom is going to want to react. It's much easier to give up an electron than it is to gain 7. So that's what sodium does. It donates an electron to an atom that wants it. So sodium's going to end up with only 10 electrons total, while there are still 11 protons in the nucleus. Recall that protons are positively charged. Electrons are negatively charged. So since we lost an electron, there it is, there's 1 more proton than electrons, 11 versus 10, so this atom will have a positive charge. We call that the sodium ion, and what an ion is a charged atom. This should have a plus sign here. It was missing. All right, now let's look at this side of the equation. This is chlorine. Its atomic number is 17. There's 17 protons in there in this nucleus. Here's 17 electrons. when we distribute the electrons according to the octet rule, 2, 8, well, there's only 7 left for the third shell, so it's easier just to gain 1 instead of losing 7 electrons, and that's what chlorine does. It'll take the electron that sodium wanted to donate, so there it is. So now chlorine has 18 total electrons, but protons never change. There's still 17 protons in the nucleus. That means there's 1 more electron than protons, which makes this atom negatively charged. You can see the negative here. Positively charged ions are called cations. Negatively charged ions are called anions. And remember, an ion is just a charged atom, where a cation and anion are more specific. They'll tell you positive or negative. So we have 2 ions of opposite charges, and what do opposite charges do? They attract each other. Now these 2 atoms bonded together, and we call that an ionic bond. Sodium chloride is the result, which happens to be salt. So what does magnesium with a +2 charge mean? Well, is this a cation or an anion? It's positively charged, so it's a cation. So what happened? It lost or donated electrons. How many? 2. In the previous slide, the ionic bond created sodium chloride, which is salt. Here is salt and how the sodium chloride, this Na should be positively charged, how they arrange themselves in these crystals. But what happens when you put salt in water? Salt dissolves. What's happening at the atomic level is all of these ionic bonds holding these ions together start breaking. So now all of these little ions, chloride ions and sodium ions, are floating around in solution. Those are called electrolytes. That's answering this question right here. We use these charges in our body to perform different functions like muscle contractions and nerve impulses. But the point here is that ionic bonds are relatively weak. When you put them in solution, they'll dissociate, or you can say their bonds will split apart and their charges will be floating in the solution.